aggregated. So this is the bitmap of the block act. So this is to give you all an idea that you can run simulations in NetSim. You can run complex networks with number of nodes. You can enable or disable Wireshark in any of the nodes, and the Wireshark, just as it captures real packets in the real world for analysis, the same Wireshark can be used to capture our virtual packets. We have written this interface with Wireshark, and then you can open Wireshark and you can study all the fields of the packet. You can study the block act, you can see the frame aggregation and so on. So let us quickly look at the source code of the block act. We'll go to the 802.11 project again. Here in 802.11_maxframe.h, the block act size is defined. So here you can see that for the block act size has been defined as per the standard. Then in 802.11 block act frame, the variables that are part of the block act is available. So these are the variables that are part of the block act, and it is this that has been captured and shown when the packets have been transmitted in Wireshark. Next, in 802.11_maxframe.c, the function create block act packet is used to create and initialize various parameters of a block act. The reason that I am explaining some of these files and codes to give you an idea is because several of our users are working on R&D which involves modification to the frame aggregation or to the block acts working. Next, in the file csma.ca.c, the function process block act is used to process the block act when received by the source node. Here the bitmap value is verified for each packet, so you can see the if loop. Here the bitmap value is verified for each packet to determine whether the packet is successful or if it is a failure. Each bit of this bitmap represents the status of the MPDU. .11ac file layer combines MIMO, which is multiple input, multiple output, and OFDM, which is orthogonal frequency division multiplexing. MIMO refers to the simultaneous transmission of multiple streams of data using multiple transmit and receive antennas. 802.11ac currently supports SU MIMO, which is single user MIMO with a maximum of 8x8 antennas. OFDM, which is orthogonal frequency division multiplexing, is a method of encoding digital data on multiple carrier frequencies. A large number of closely spaced orthogonal subcarrier signals are used to carry the data on several parallel data streams or channels. Each subcarrier is modulated with a conventional modulation scheme such as QAM or PSK. The combination of OFDM and MIMO serves as the foundation for 802.11ac and other advanced wireless and mobile communication standards. This is because it achieves the greatest spectral efficiency and therefore delivers the highest capacity and data throughput. Let us also look at the source code of MIMO OFDM. The file 802.11ac.c file contains the codes related to OFDM and MIMO. The function OFDM MIMO init initializes the MIMO and OFDM parameters relevant to 802.11 AC. As you can see, bandwidth 20, 40, 80 and 160 megahertz are supported, and you can see the respective 5 parameter initialization. NetSim is probably the only network simulator supporting 11 AC 5 gigahertz channel with 160 megahertz bandwidth, which gives a maximum throughput of up to 1.3 Gbps. And this in turn means that NetSim has time refinement in the simulation down to 0.1 nanoseconds. To analyze the throughput for various configurations of OFDM MIMO, we created a network scenario as shown and ran some simulations. The scenario consists of a wireless node connected to an access point, which is in turn connected to a wired node via a switch. We have set the application from the server to the wireless node, and the rate of download is set as 2 Gbps. So initially we set 4x4 MIMO configuration and vary the bandwidth from 80 to 160 megahertz. And as you can see in the graph over here, 4x4 at 80 megahertz gave us a throughput of about 780 Mbps, while the same thing at 160 megahertz gave about 980 Mbps. 8x8 at 80 megahertz gave about 980 Mbps, and 8x8 at 160 megahertz gave a throughput of 1.1 Gbps. These were some of the simulation results that we got for this particular simulation. The performance of 802.11 wireless LAN is influenced by the wireless channel characteristics or the signal to noise ratio, particularly when operating in harsh environments. In order to cope with the SNR reduction, the 802.11 specification suggests to adapt the transmission rate dynamically, since modulation techniques employed at lower rates are more robust. However, the standard does not define any rate adaptation technique. Yes, some of them are telling that there is a voice problem. I'll just readjust our microphone. We're just resetting our mic. Okay, I hope this is better now. So coming back to the discussion on rate adaptation, the standard does not define any rate adaptation technique and leaves the actual implementation to the device manufacturer. NetSim provides support for 2 rate adaptation algorithms in WLAN, which is generic and Minstrel. These are disabled by default in NetSim, as we will be showing you. The generic rate adaptation algorithm is a simple adaptation algorithm that is implemented in NetSim, and the way it works is that the data rate is increased by 1 step upon successful reception of 20 consecutive packets, and the data rate is decreased by 1 step upon 4 successive failures. So we will just show you the code for this. The file generic rate adaptation.c contains the codes related to the rate adaptation algorithm in NetSim. It contains various functions like get max phi index, get min phi index, packet drop notify and packet receive notify. The function packet drop notify checks whether there has been more than 3 consecutive packet drops. And if there are 4 consecutive packet drops, then the phi rate is decreased. The function packet receive notify checks whether there is more than 19 consecutive successful packets received, and if so, the data rate is increased by 1 step. Now for some researchers, they can change these numbers 3, 20 for the number of successful, the number of failures. They can change it very quickly by just making a change in one variable and then study the effect of these new numbers on the WLAN throughput. Now we'll go to the more complex Minstrel rate adaptation algorithm. The Minstrel rate adaptation algorithm is an automatic rate adaptation algorithm that relies solely on measured performance with minimum assumptions. It responds to changes in the environment and auto updates, and it compares the performance of the algorithm at all times. So the core of the Minstrel rate adaptation algorithm is the exponential moving weighted average. And the table shown below shows the 4 rates that are used by Minstrel, namely best throughput, random rate, best probability and lowest base rate. The algorithm is based on the EWMA of successful packets to determine which rate is to be used.